Hi everyone. My name is Rangshetty GSN Singers. I am from EC student D section. My subject is physics, and my tech talk topic is quantum optimization and quantum learning, a survey. So let us start about quantum optimization and quantum learning. First, we discuss quantum optimization. Quantum optimization not only maintains the powerful global search ability and excellent robustness of intelligent algorithm, but also observe the advantages of quantum computing by using the parallel computing ability of quantum mechanism. It is able to improve the diversity of population and accelerate the search speed, thus greatly improving the efficiency of intelligent optimization. According to the exciting research, contents of hotspots of mainly improvements are summarized. This quantum optimization, there are some topics. Let us discuss about it. That first is quantum evolutionary algorithm. Quantum evolution algorithm is a new evolutionary algorithm which adopts the concept of quantum computing mechanism combined quantum theory with genetic algorithm for the first time. The concept of quantum genetic algorithm was introduced and the field of integration of quantum computation and evolutionary computation was opened up. As Hahn proposed a genetic quantum algorithm GQA and then extended it into a quantum evolutionary algorithm compared with traditional one. Quantum evolutionary algorithm has the advantage of rich population diversity, good global search ability, fast convergence, and easy integration with other algorithms. Over the past decades, um, quantum evolutionary algorithm has attracted wide attention and yield fruitful results. And then the next topic is quantum particle swarm optimization. Swarm intelligence is a new optimization method since its emergence in the 1980s. It has attracted widespread attention. It has been taken a research hotspots in the field of optimization and the furniture of interdisciplines. Swarm intelligence. Swarm intelligence is a heuristic search algorithm based on swarm behavior of optimize a given function whose optimization process embodies the characteristic of randomness, parallelism, and distribution. Uh, a particle swarm optimization algorithm was quantum behavior is proposed in the motion state of a particle is described using quantum uncertainty principle, and the quantum mechanism is combined extend the quantum particle swarm optimization to the field of multi-objective optimization. In this next topic is quantum immunoclonal algorithm. Article immune system draws on the experience of information processed in the vertebrate immune system, constructing new intelligent algorithms based on immune terminology and basic principles will provide novel ideas for solving problems. Immunoclonal selection algorithm is an intelligent algorithm with strong local optimization abilities through increasing the population size, which adopts clonal operators to keep strong local optimization ability. Quantum system is a parallel distributed processing system is in nature, so the combination of biological evaluation with quantum theory will be better at simulating the process of information. And next, quantum learning. Quantum computing has shown advantages in intelligent optimization. Therefore, people put forward the idea of combining quantum theory with learning algorithm, hoping to introduce the advantage of quantum computing on this basis of exacting learning algorithm and achievements more fruitful result in this part. Two classical algorithms, quantum neural network and quantum clustering, are elaborated specially. Besides contents of algorithm and relevant research progresses are introduced and the related work are summarized. In quantum learning, there are few types. In this first one is quantum neutral neural network. With the with the advancement of psychology, neuroscience, computer information processing, and artificial intelligence conditions for exploring consciousness of human with nature, science method have become major and many valuable research result and neurocomputing has been achieved using threshold logic unit to simulate biological neurons. A well-known MP neuron M2P neuron model is proposed in which opens the prelude of neural network research in order to simulate the um, plas- plasticity of synapse. Hub rule proposed in which lays the foundation for constructing a learned neural network model. After that, a learning mechanism is added to the original MP model, and the theory of neural network is uh, put put into practice for the first time in after several decades. The development article neural network ANN has achieved extensive success in many fields such as pattern recognition, automatic control, signal processing, assistant decision making, and so on. The excellent performance of neural network makes it one of the hotspots in quantum research. In 1995, Koch proposed the concept of quantum neural computing for the first time. The thought of combining nerve computing with computing with computing with quantum computing to form a new computing paradigm paradigm pioneered in the field of quantum study. T. Miner discussed quantum neural network (QNN) comprehensively from the point of multi-universe and considered that QNN worked better than the traditional neural network. After that, new QNN model has been brought in based on Grover search algorithm and quantum associative memory model is proposed in the model of a quantum neuron is described and its mechanism and corresponding training algorithm are discussed. In the meanwhile, it is proved that a single quantum neuron can perform XOR functions that a single classical neuron cannot achieve. In this next, quantum clustering. Clustering plays a very important role in the field of data mining and is a useful tool for data analysis and knowledge discovery. The purpose of cluster analysis is to classify the simple objects into several special meaningful categories according to their similarity. Data clustering has been widely used in data mining, computer vision, information retrieval and pattern recognition. Generally, clustering methods are divided into the following categories: Gaussian-based algorithm, um, and density-based algorithm, grid-based algorithm, and model-based algorithm. As a new kind of clustering algorithm, quantum clustering as a QC attract um, more and more attention, produces a large number of excellent theoretical results, and has achieved extensive success in many fields. According to uh, according to the core idea, the algorithm quantum clustering can be divided into two categories based on quantum optimization algorithm are inspired by quantum mechanics. In the design of clustering algorithm based on evolutionary computation, the principal problem are the coding of individuals, the distance measurement, and the selection of an appropriate object objective function. A clustering technology based on genetic algorithm is proposed in 154 proposed in according to the evolutionary scheme. Evolutionary strategy is used to find optimal solution in the target space, not only to update the clustering center but also to reduce dependence of dependence on the initial clustering center. And the next is in addition a quantum clustering algorithm inspired by quantum mechanics is introduced in which uses the gradient descent method to solve the minimum of potential energy and determine the clustering center. And in addition, a quantum clustering algorithm inspired by quantum mechanics is introduced in which uses the gradient descent methods to solve the minimum of potential energy and determine the clustering center. The physical basis of quantum uh, QC is illustrated in by taking clustering as a physical system by solving Schrodinger equation uh, and using the gradient descent minima and minima of the resulting potential function can be obtained, which corresponded to the cluster center. Typical application. In this part, several typical applications of quantum optimization and quantum learning are presented from the perspective of experimental proof. Through the modeling of different problems, particle problems are converted to be solved by quantum optimization or quantum learning method. The experimental results also show that algorithm based on mechanism achieve better results and possess great application through few types. In that, QWEA applied to SAR image Segmentation. The goal of segmentation is to partition an image into disjoint regions. In this part, the problem based on partition clustering is viewed as a combination or combinatorial optimization problem. The improved algorithm QWEA firstly uses watershed algorithm to segment the original image into small blocks. Then through QEA, the optimal combination is obtained to form the final result. Next, dynamic content context corporate QPSO applied to medical image segmentation. The QPSO, then the updating method of particle will determine the performance of the algorithm. In this paper, we incorporate a new method of dynamical updating in the context vector to update particles and quantum inspired image clonal multi-objective optimization based on the concept of principle of quantum computing and a quantum inspired clonal multi-objective optimization algorithm QICMOA as hence it is proposed to solve extended 0 by 1 mm, KNASP problem KNASP problem. Next is quantum clustering for community detection inspired by the mechanism of quantum computing. QC is applied to complete the clustering of the feature space to find the corresponding communities in the communities in the network space. And conclusion, hence the conclusion, this paper summarizes the exciting quantum algorithm for the two aspects, quantum optimization and quantum learning. Firstly, the related concepts and development history of quantum optimization and quantum learning are introduced. Then classical algorithms are described in detail and their development is summarized. Finally, related experimental proof are given as a new kind of global uh, given as a new kind of algorithm. Quantum intelligent algorithm combine the high efficiency of global search with a high parallelism, powerful storage, and computing advantages of computing quantum computing perfectly, which can effectively avoid the shortcomings of intelligent algorithm and moves the efficiency. Experiments also show that compared with traditional intelligent algorithms, quantum intelligent algorithms have shown strong competitiveness, competitive and possess great potential. Thank you.